Hello, everybody. Hopefully you can all hear and see this. We're slightly early, so we're just going to give it a few minutes and then we'll get going. We're on a pretty tight time frame, so when we get going, we'll have to get going. But I think we've got how many people at the moment? 10. I think we'll probably give it till 10:01 and then we'll crack on. So just sit tight while we wait for people to join. Jack, you can see my screen. Everything okay now? We're gone live.
Yep, everything's fine.
Hear me okay?
Yep.
Cool. We've got 14 people now. 10 o'clock. Right, I'm gonna kick off because we've got a lot of content to get through. I'm gonna start by saying thanks to everybody who's joined. It's really an awesome turnout. We got a really good response to the invite. A company like ours really relies on the people who are early adopters. It's new technology. It's reasonably technical technology. So all the people who are attending this call, we're kind of relying on people like you to help take this market and this product forwards. So we're really grateful for everybody taking the time out today to attend this meeting, and hopefully we can add some value and share some of our thinking, our technology that you'll find useful. We're going to, through the course of this, there's a Q&A section. I think you can see this Q&A section at the top of your screen. When we're going through, you're going to be muted. We'll get an opportunity at the end of the seminar to answer directly some of the questions that you fielded. But type away in the background in that Q&A section. John Haddon, who's on the call, is our head of tech. He's going to be responding to some of those, and we'll pick some, friendly, easy to answer questions at the end that we can then discuss with the group. I'm going to just start with some introductions on the first slide. So I'm John Lewis. I'm going to be hosting today. I'm one of the founders of Lewis Woolcott. I'm a delay and commercial expert by background. I've been using P6 for 20 years and planning software doing delay analysis. I'm the inventor of Logic Plus, so you've got me to blame for it. And but I've been working with two guys that provide the code and the technical insights who are on this call today as well. So we've got John Haddon. Say hello, John.
Hi, everybody. My name's John Haddon. I've been working in technology for more than 20 years. My background is software development, analytics, and machine learning. And I'm head of technology now for Lewis Woolcott. It's good to meet everybody on the call.
Thanks, John. And then we got Jack, who's the younger, handsome member of the team.
Thanks, John. Good morning, everyone. I'm one of the main software developers on Logic Plus. I'm really keen to show it off today.
Thanks, guys. So we'll come on to the problems that we're trying to solve with Logic Plus, and there's a theme that runs through these problems, and it's almost like with planning software, the great benefit and the great attribute of the planning software is the fact that it can filter and combine and collate masses of data. But that great strength of this planning software like P6 and Microsoft Project Enterprise and Asta, that great strength can also be a weakness. And what we've got today is we're going to show you hopefully software that allows simple access, where you don't need that skill set and that expertise to be able to access that data. And we're going to unpack that problem and just the complexity of traditional planning software, and hopefully the simplicity and the speed of Logic Plus by comparison that really brings planning, the detail that's contained in these planning programs to the non-planner. So that's a big part of the market that we're trying to target. And on a similar theme, the Gantt chart is a great invention. It's a wonderful invention at providing a snapshot over a time frame of a program or a project. But it's not great at looking at the evolution of that project over time. It's a very one-dimensional tool, a Gantt chart. And pretty much all analytics that exist in planning software are in that Gantt chart view that's constrained by date. So you're looking at a date range, and you might be able to look at variance over that date range, but it's the Gantt chart itself is the constraint. And again, so the problem we're trying to solve with Logic Plus is how can we get better insights from the data in terms of the evolution of a project, the evolution and changing nature of a program, and use that to provide greater insights through trend analysis and better analytics that are more 3D compared to that 1D flat image that you see within conventional planning software. And then the third problem that we're trying to solve today, and we'll unpack each of these issues in more detail, is that there's this conundrum in planning where once an activity is actualized, and so in a Gantt chart view, once an activity is completed, it by definition has zero float. It can't move. It's been actualized. And this creates a problem because if the dates don't align with the logic that was defined, then the planning software has this conundrum. What do I do? Do I rely on the dates or do I rely on the logic? And it's a problem that's plagued planning software, and it's not something that the developers have been able to overcome. And there've been workarounds, but they've not been good workarounds. So that's the other key, that as-built conundrum that we're calling. That's the other thing that we're trying to solve with this planning software. So we'll come on to problem one, and we're going to dip into Logic Plus throughout this demonstration. We didn't just want to show you the software without some examples. Building on this complexity, and every major project is controlled by a Gantt chart of some description, and these projects, particularly the ones we work on, they're large complex projects. We see schedule files that run to 40,000 plus activities, massive code base, millions of logic links. And the database, I mean, I love P6. I've used it for 20 years. I love the complexity. I love the group and sort functionality that it affords you, but it takes a long time to learn. If you're a non-planner, you've not got that experience with P6, it's a difficult tool to get access to and start to maneuver. And when we were preparing this slide, I was thinking, well, a good example of the complexity of P6 might be the number of types of start that there are. And it surprised me to know that when I started counting the number of different types of start you see in P6, there are 13 different types of start. And so knowing which type of start to use in a filter is a key learning, whether it's planned or actual or anticipated or baseline, and knowing when to use them. That takes some learning. And what we wanted to be able to do is simplify some of that and find a faster, simpler way for the non-planner to access this data, because it's good data. But and we've got a few examples of short videos that show you how we streamlining this process. And right from the start, when you're using P6 or other planning software, uploading files is a bit of a chore. It takes time. And we're going to run this video in the background now. I'm going to hit play. And what you're looking at here is the upload of 8 files, or it might even be less, might be 6 files. Logic Plus on the left-hand side, which is our software, is uploading these files into the database. And on the right-hand side, we're running a comparison for how long it takes P6 to upload these files. Now you can see the clock stopped at 14 seconds on the left-hand side. So all of those files are now in the Logic Plus database. And you can see we're still going on the right-hand side with P6. And it stops at 3 minutes. So it took 3 minutes to upload those files. Now, if you work in planning and you're spending a lot of time, that is just dead time. And it's a painful exercise you've got to go through, particularly when you're opening new projects and you've got a lot of XER files to update and upload, particularly in the work we do in forensic and delay analysis as well. That was one example, and it's right at the start. It's when you start your P6 journey, the upload process is slow and clunky. Here's another example. So this is a really good example, just creating a 1-week look ahead. It's something that everybody wants to do, or a 4-week look ahead, or a custom look ahead within planning software, because they want to know what they want to work on next week. And again, we're looking at mouse clicks now, because mouse clicks are a good indicator of how complicated a system is to use. So on the left-hand side, again, we've got our Logic Plus software, and we're going to count the number of clicks it takes to do a 1 week look ahead. And on the right-hand side, we're going to configure a 1 week look ahead in P6. And so, and these videos are targeted at the non-planners amongst you. So so on the left-hand side, we've stopped at 3 clicks. Now, on the right-hand side, for the non-planners, what we're doing here is we're creating a 1 week look ahead using the filtering system. And you can see we're using terms like date-to-date plus 1 week. And in P6, it's DD plus 1W. That's the abbreviation. But you've got to know that. You've got to learn that DD plus 1 week equals the time frame that you're looking for. And then you also need to know that you might filter on start and finish dates, but you might not realize that if you want to know what's happening next week, you also need in progress activities. Now, there are some default filters within P6. I think there's a 1 week look ahead, but if you want any kind of custom filtering, it's a real problem. You need to be able to navigate complicated acronyms within the software to be able to get to these filters. So we're going to just start off by giving you a really quick run through of some of the simple, fast ways that you can perform tasks in Logic Plus compared to Microsoft Project or Asta or P6, with a view to bringing this data and making it more accessible to project managers, construction lawyers, contract administrators. So I'm going to stop sharing my screen a minute, and Jack is going to open up Logic Plus for you. So what we can see here is, Logic Plus is on the screen now. It's configured in a way so that it's going to look like a conventional piece of planning software. Down the bottom of the screen, you can see that we've got 4 files uploaded into Logic Plus. You can see those files. You can see the data dates for those files. So when the progress is being updated to. So it's going to look and feel a lot like a typical Gantt chart, but we've got some filtering that we think is easier for you to use as a non-planner. So if we start by just looking at a start filter, so instantly you click that right corner on the start column, and it's going to look and feel a bit more like Excel than a filtering system in P6. And you can very quickly see you've got filters that are pre-configured for yesterday, today, tomorrow. You don't need to understand jargon to know what a filter for yesterday is going to do. And if you drop down that box there, you can see that you've got filtering that would allow you to filter within a date range as well. So it's just a more user-friendly way of filtering data. We've also got key buttons that are going to help you identify the filtering. So if you look at the month filtering along the top, for example, you want to see what's happening next month, you can just click a button, group by month, and it will group those activities by month for you. And so it's one mouse click to give you this ease of access for group and sort. Similarly, we've got these buttons along the top for WBS. So if you wanted to just click, like on a level 2, so you're not interested in detailed hierarchy, click on the level 2 button, and it's going to group by level 2. Click on level 6, Jack. And it's going to add more detail into your WBS structure. But again, it's kind of there. It's at the top of the screen. It's simple. And that's not to say that because it's simple, we don't have the detail that you can derive from P6. So if you wanted to add a column, it's pretty easy. You go into a column chooser. Now, the columns that you can add, you've got the list of columns that you can add, including custom fields for traceback, which we'll come on to in a minute. But you've got a lot of different options within here. But you can go as simple or as complex as you want. So for the guys who like detailed analytics, we're going to fill your boots with that in a minute. But we've also got it pretty simple for the non-planner. And then I think we'll just show, if you wanted to nominate a baseline, it's super easy. You're not going into maintain baseline, assign baseline. You literally just click an arrow, and you're going to select whichever of those program files you want to use as the baseline. If you had 10 files in in here. You could just click one of those 10. Using in analysis, that include an analysis, it means that if we're going to run tracebacks, which we'll come on to later for delay analysis, you can select which files you use as part of that delay analysis. And just finally, on the simplicity, now we've uploaded these files into the database. Whichever one you want to view, you simply just drop down that arrow at the top, and whichever one you pick, it's going to display on the screen. So you don't need to come out the software and go back in again. It's just there. It's all in one place. It's pretty easy. You can see it within a couple of mouse clicks. So I think first things first, we're doing this deliberately. Obviously, there's a schedule viewer market that's out there, and we want to be able to compete with that schedule viewer market. But we want to add more benefits and more features to our software so that we've got an edge in the market. And so this is why we're starting off with this part of the demo. So hopefully fast and simple is the main takeaway. Jack, if we just come back onto, I'll start sharing my screen again. So we're just going to drop back onto the slideshow, and we're going to move on to the next point. So this problem that I touched on in the opening dialogue, the problem that plagues Gantt charts is the fact it's a Gantt chart. So you're always going to be looking at data in the context of activities over time. And you might work on a project where you've got weekly and monthly updates, and those weekly and monthly updates take place over a series of months. It might take 30 months. There might be 30 months of data that you could be analyzing and relying on. But when you're viewing it in the Gantt chart, all you're really seeing is the baseline variance. And yeah, you might be able to assign multiple baselines, but you're still constrained by that Gantt chart view. It's variance in a Gantt chart. And what we've done here is we've given you an example of assigning a baseline. At the bottom of the screen, what we've said is, look, there are ways within P6 that you can or project that you can analyze the evolution of an activity over time. So down the bottom, what we did is we opened up multiple files and we grouped and sorted by an activity ID to look at how that bar changed over time. And you can start to see a bit of a trend for that bar, but it's moved to the right-hand side and it's got longer. But when you're doing this type of group and sort across a program file that has 40,000 activities, it becomes exceedingly complex. And what do these trends mean? And doing this in the Gantt chart it's too much for the human mind to take. So most people who want to do this type of analysis have to start moving this data out into another platform so that they can get meaning out of it. And it's complicated, and it's not the best system. So one of the things we're trying to do now, we've got all the data in a database, and we're going to move back into Logic Plus in a minute, is we're trying to identify meaningful trends that are accessible to planners and non-planners that don't need significant amounts of manipulation and data exporting. So I'm going to stop sharing, and we're going to run through some trend analysis in Logic Plus, and we're going to look at how you can identify change and trending over time, because these are key things that I think the discipline of cost has got very good at trend analysis, but it's something that planning kind of lags behind. I don't see a lot of good trend analysis. Obviously people are running risk modeling on schedule files and tornado analysis, but trending isn't done well, I don't think. So let's start by looking at some trend analysis across these files. So we've got 4 files in here. Let's start with trends, I reckon. You want to do activity? Let's do trends first, Jack, and then we'll So just by what you'd have seen there, Jack just went up to the trend, the reporting button, and click trends. And then these are the custom generated trend reports that come out of Logic Plus. And I'm going to explain these to you as quickly and simply as I can. Really what we're looking at here is the top chart is showing you float over time, and you can see these orange lines that kind of come down. What those are displaying is baseline finish date. So you can see that there was a baseline finish date of the 30th of the 3rd, 2025. You can see that the latest finish date in the latest program file is the 18th of the 6th, 2025. And then what you can see is you can see a trend line. that trend line, the dotted is showing you, well, that's forecast, and the solid line is showing you this is what's been reported across the different files. Now, the way we create this line is we look at all the activities in the Gantt chart. So there might be 40,000 activities, and we look at what's the average float per activity in that Gantt chart. And then we start to model that average float over time. And so if we had 8 files uploaded, we'd get more data and probably more reliable trend data. For ease here, we're just using 4 files. But what you can start to do is you can start to predict when float goes negative. And so when you cross that 0 float threshold, where Jack's hovering now, you can see that we go 0 on the 30th of the 6th, 2025. And that's before the end of the project, before the current date that we're predicting. Now, that's a good indicator. When total float goes negative, it's a good indicator that you've got a problem in your program file. And that date that you're aiming for probably isn't going to happen. It's not a perfect measure of prediction, but it's a really reliable indicator. It's a good trend that you can determine from a lot of data, but super simple. 3 lines to understand. We said we were going to finish here. We're now predicting we're going to finish here, but we're going to run out of float at the current trend before we're predicting to end the project. So it raises a flag, and it's something that a project manager can use, or a CA if they're managing a subcontract. The graph below is showing project progress over time. And there's different measures of progress within schedule files. Now, this file that we're using doesn't have resource data, but if it had resource data, we could look at the rate at which we're earning value, for want of a better word, the progress of resource labor units. So we could be modeling resource labor units over time. The different measures that you have within P6, the conventional ones, physical progress and duration progress. And what we're doing again is we're looking at the way these progress lines are being reported. How much progress are we achieving in a month in the different files? And then we're trending those out. And again, we've got our vertical line. So we're showing that if we carry on the physical trend line, we're going to be later than the latest forecast date. And so we can see a bit of a trend appearing here, from the graph above and this graph. We can see that we're probably going to be late. The graph is indicating that we're going to run out of float before the end of a project, and it's indicating that at the current rate of physical progress, we're going to be late. If we trend that line out, we're going to be late. And it's not the perfect measure, but it's a really good indicator. You would start to spend a lot more time analyzing where you're lagging behind and what's going on in the program file. Let's just go down to the next trend report. So this is a bow wave chart, and a lot of you, it's kind of something that I've become more familiar with in my career. I've heard this bow wave analysis used a lot in planning terms, but I haven't seen it expressed as a standard export. And what that bow wave analysis really does is it looks at the number of activities that are planned to be completed in a month. So if you said you were going to do 15 activities, or in this case, we said in the initial instance, we were going to do around 90 activities concurrently in a month. That's kind of your peak production. You're going to do 90 activities concurrently in that month. And that's what these lines are modeling. Now, with bow wave analysis, what we're doing is we're saying, well, that's what we said in the baseline program. We said we were going to do 90 a month. But as times evolved and things have gone on, we can see that now we're doing more. We're saying we're going to do 180 activities concurrently in a month, and we're going to do those 180 activities for a longer period. And you can just see, and when those 180 activities occur, have moved to the right hand side. So this is why it's called bow wave analysis. You can see this body of work that's flowing through the program, but yet when you look at the end date, you can see that the end date's looking remarkably the same. So the questions that you would raise are, have we doubled the number of, management resources to cope with all these activities that we're going to be coping with now at peak production? Or if we were to resource constrain these distributions, really what we're looking at is the date's going to move to the right-hand side. Now, these are really good indicators. Again, these all come from the same program files, and they're all, to me, suggesting an indication that this project is not finishing on time unless we take some significant action to increase resource numbers, or to look at just the ways that we can mitigate the delays that have been incurred. We've got an issue on this project. And again, when I look at the bottom distribution, what this is looking at, this is the way that delays have been reported in the program file. So you can see that over time, the forecast completion date, whether it's practical completion or whatever you select, we can see the way this date has moved in the different reporting windows. And if we start to predict this date out, we can see that we sail past the end date that we're currently predicting. So all these distributions are starting to suggest that this project's got a problem, and this is the type of three-dimensional trend analysis that it's impossible to get out of a Gantt chart without serious manipulation of data. And we're just going to finish on looking at project trend and changing over time by going back into now. When we do the delay analysis and when we're doing this trend analysis, it's really interesting to be able to drill into the detail. And so again, because we've got these files in the database and all files are accessible, Jack's going to go on to activity history down the bottom. And we can start analyzing what various activities have done. And so every activity is expressed here. We can look at the way these activities have changed over time from a variety of attributes. So if we go for early start, for example, let's look at how early start have finished. So scroll down a bit, Jack, just so we can see like complete walls of data. So here what you can see is this is showing early start dates in the different, as for an activity as recorded in the different files. Now it changes color because it means it's changing. So you can filter really easily on a specific activity. So if you found that one activity was on your critical path and you wanted to know how that activity had evolved, you can go to this view at the bottom of the screen and you can see how it's evolved over time. You can do it for date, or you can do it for float, maybe show float or duration. So here you can see how floats changed over time. In some instances, it might not have existed in that file. So, if it's a new activity, and we'll come on to identifying new activities in a minute, you can see that it'll return a void. You're going to get a blank, but you can look at float, or you can look at duration, and you can even look at, and we won't do it now, but you can even look at like predecessors. So you can analyze how predecessors or successors have changed from the different files over time. So look, getting this three-dimensional view of how a project evolves and how it changes and what those changes mean and trend for the output of the project, that's a big part of what we're trying to do here. And then Jack, if you just, I'll come back on and we'll return to the slides. So we're going to move on to our third and final problem. I wanted to try and save as much time as possible for this, because this is a problem that's plagued planning for a really long time. All my career, it's always been an issue of looking at the left-hand side of a data date. So for those of you who don't know and aren't familiar with planning, this is the data date. And if you had a program file in P6 and you just clicked the standard filter for longest path, it's going to stop at the data date, because everything to the left-hand side by default has zero float. It's actualized. It no longer has float. So logic does not provide the answer to that left-hand side of a data date, because it can't do a forward and backward pass on all activities that it return everything. So they return nothing in their standard filter, and this is an issue that's trouble planning software. And even if you set up custom filters, the problem with the custom filter, so if you go into P6, for example, and you set up a filter for longest path equals yes, what it looks for is it looks for these attributes. You can see down the bottom of the screen where it says driving. So if that driving box is ticked, then it will return it in a longest path filter to the left-hand side of a data date. The problem with that is that box returns the point at which it may have been driving in the past. Once it's ticked, it stays ticked. And it creates these kind of anomalies where when you're looking at, this is a longest path equals yes filter, we've got concurrency everywhere. Because at some point in time, these activities might have been driving. And the problem you have is down the bottom, the graphical representation. Once upon a time, this activity drove the other one. But when they were actualized, you can see that this activity started in advance of the other one. Now, that might constitute a delay, but sometimes these gaps are huge. And what it was is it's bad logic, changing construction sequence, or that another predecessor drove this task down the bottom of the screen. And so for this reason, you get really poor as-built information. And this is a lot to do with, delay analysts. Delay analysts are trying to work out and untangle this mess to the left-hand side of the data to identify really what was driving the critical path in various points of time. And that's, an onerous expert task. And there's not many of those guys around. So we've designed this algorithm, and we'll run it now in the background. I'm gonna hand over to Jack again to try and automate this process for the non-planner. So if you just want to know as a contract manager or a project manager, contract administrator, where the delays have occurred and what that critical path looks like, we've tried to automate that as part of the software. So we're going to show you this algorithm. We're going to try and explain to you how it works. It is quite a complicated bit of the software, but it doesn't need to be. If you don't want to understand how it works, you can just click the button. But if you're a delay analyst and you really want to get into it and you want to start analyzing, then we've got that complexity for you as well. So let's go to the bottom activity. So Jack's just going to click the button to take off the WBS filter, and he's going to slide to the bottom. And we're going to pick the last activity, which is R2 commissioning. We're looking at a solar project. This button he's about to click is Start Traceback. So if you aren't a planner, you don't want to be a delay analyst, and what you want to know is just tell me what's driving my as-built critical path, or tell me what drove the critical path to a certain date. And you can pick any activity to run this algorithm. So it doesn't have to be the last activity, any activity down that chain of logic. If you want to know what's driving it, click it, hit the button, and it will tell you. So let's hit the button. So what that's just done, and we'll close the analytics for now. We'll come back onto that. Let's go on to the candidate scores. We're going to pick a candidate, and we'll explain to you how this algorithm runs. So let's pick an obvious one. Yeah, pick that one. There you go. So now we've picked a candidate. This is the best way I can think of to explain to you how this process works. So within a file, there are lots of different attributes. So in a typical P6 Microsoft Project Asta file, there's a lot of different attributes that are in there. Things that may imply an activity relationship, even if they're not bound together with logic. Typically, somebody would draw a logic line in there, and they would say, well, yeah, it's driving, and they draw that logic line. But there are other things that may imply a relationship besides just logic, and that's why we called it Logic Plus. And if you look at these attributes, we've identified 15 attributes that may imply a form of relationship between two activities. And Jack's just scrolling along here. You can see these attributes. John Haddon on the call gives a really good analogy. When we're trying to work our way backwards to the start of the project, it's like find different files to work our way back to the start of the project. And what this is doing, so we upload all the activities into a database. And now what the algorithm does is it starts to analyze each of those activities. And in this instance, what it's doing is it's saying, okay, well, I'm looking for a predecessor activity. So for it to be a predecessor, it's got to be reasonably close in terms of date to the place I'm stood. So imagine you're on a stepping stone trying to work across a river. I'm stood on a stepping stone. I'm looking for the next stepping stone to get backwards. What's near to me? That's one of the first questions that you've got to ask. Where can I jump to? And so you can see here you've got scored for implied link. If it's close in terms of date proximity, it's going to get a scored for implied link. If it's got a logic link, then we're going to give it a bigger score because we know that it was within the contemplation of the planner at the time that these two activities were linked. But then there's a host of other attributes that might imply a relationship. For example, if they've got a primary resource, if they've got the same resource. So if you're building a wall and there's a bricklayer building one wall and then he moves on to a new wall, then it's implied that there might be a link because they've got the shared same resource. Equally, if you see one activity move and there's variance and the same variance as the successor activity, it's implying they move together, like they were dancing together. So there's an implied link between there through variance. And what we do is we analyze all these different attributes from all the schedule files to identify the best candidate for the predecessor. And if you don't want to get into all this detail at the bottom of the screen, we provide it really easily for you. So Jack, just scroll down the bottom. At the bottom of the screen, you can see the alternatives. Obviously, the algorithm returns the best one, the rank 1 candidate. But equally, if you didn't agree with it and you wanted to overrule it, and let's say you said rank 2 was your preferred option, you can click on rank 2, and then you can simply resume the algorithm from rank 2. Now it's going to ask you, why are you resuming from rank 2? And you might just say, well, it's construction common sense that was the activity. So you can type in your reason why in here, and it's going to record it. And then you simply resume the trace back, from that point in time. And it will give you a new piece of delay analysis and tell you where the prolongation and everything occurred. I'm just going to draw your eyes to one thing within this analysis. So you can see where green has occurred within this traceback. These are new activities. So these are activities that did not exist in the baseline file. And of course, you can change the baseline file just by unticking or ticking. But again, it shows something's interrupted the planned chain of logic. We've got these 3 or 4 new activities that are now in this planned chain of logic. So we've got that area to sort of focus on. And again, we can look at which file they occurred in. Now, there's some really clever things that this file will do. So if you uploaded multiple schedule files from multiple different planners, even though they're not bound together with logic, it would navigate its way to a critical path across all schedule files, because it's not just relying on that one logic attribute that conventional planning software relies on. And then because we've cracked this as built, obviously not cracked causation, but we've cracked the as built conundrum. What this opens up to us is a host of different delay analysis reports and charts that again make delay accessible to the non-planner. So don't forget, I've talked a lot of complexity here, but really what Jack did was clicked one button and it provided this as planned, as built analysis. If he now clicks on the delay charts, what this is showing you is where the deviations from the baseline occurred. And if you click at any point down here, so let's pick a point where there's been delay, Jack. So yeah, it highlights. You can see that there it's going to take you to the location where the delay has occurred. And where he was then, if you just click on the place you were, Jack, it's reasonably interesting. So where your mouse was, yeah, about there. Try there. You see activity ending 8750, Jack? Click on that one. Yeah, 8750. Up, there, that one. Yeah, so what you can see there is that when he hovered over it before, you could see an increase in the delay. There you go. And that's because you can see that the baseline occurred before the predecessor, and in this instance it's now after. So there's a jump in delay, and you can see that in the graph in the distribution underneath. So you can start to see, and you can also see where they might have changed construction logic, where you can see the delay go down. You can see it kind of climbs up a mountain, Jack, show at the bottom of the screen where it climbs up the mountain, up, right. I mean, it goes down. Well, I'm willing to bet there's a change in construction logic at that point in time that reduced the extent of the delay, where we've changed the logic. So this graph is interactive and it navigates you to where the delays occurred. If you go onto the delay analysis tab, Jack. So within this delay analysis tab, it gives you a breakdown of the different types of analysis. So you can look at prolongation. You can see an activity's got longer by 50 days. Click that activity. And it takes you to that activity. There you go. You can see that we've got a nice short baseline and a nice long activity. So you can see activity prolongation. And all this information is pretty accessible. You can interrogate it without being a delay analyst. You can write this trace back. So when you're happy with this trace back, you can write it to the XER file, import it back into P6, and then analyze it and do what if analysis. Or you can export it to an HTML file. So if you wanted to provide this as a reason for not accepting extension of time analysis. You'd say, well, look, we've picked your milestone and we've compared it to the Logic Plus traceback, and we found that the Logic Plus traceback returned a different critical path. You can provide this in an HTML format. Yeah, and scroll down, and this HTML format tells you the scoring system and why every activity was returned within that critical path. So it's telling you this is the algorithm that we used. This is why we've returned this as being the critical path, and this is why we don't agree with your position, because the algorithm doesn't agree with the position you're putting forward. And again, this is auto-generated, and it would also show, you know, the points where you've overridden the algorithm. So pretty much, pretty frequently, what you'll find is that you don't need to override the algorithm very often. And so your main talking points, your points of contention are the places where you've overridden it. So we've given you a real whistle-stop tour of the software. I'm just going to come back on and give you a quick recap on what we talked about, and then we'll do Q&A. So I'm just going to share these slides one more time. So I guess the things that we wanted you to take away from this presentation were that we've created a tool that hopefully is fast and simple, and it's going to hopefully make planning and programming more accessible to non-planners, and increase the understanding of program files for everybody within the project team and organizations. We've hopefully examined these trend analysis issues and that one-dimensional problem that you get with conventional planning software, and the fact that we can do more detailed and robust trend analysis. And then obviously we've looked at the problems, that as-built conundrum that conventional planning software has, and hopefully solved it. And that opens the door to this type of delay analysis, this automated delay analysis. And there's all kinds of upsides with automated delay analysis, because it removes the accusation of bias. It's certainly a hell of a lot faster. You know, even when we're consulting for independent expert analysis, we'll start with Logic Plus just to get that real speedy. Okay, where am I looking? What did the files tell me? You know, the files may be inaccurate, but Logic Plus gets me to where I need to be super fast. And then it's that ability to export it simply and then share it. So we're going to probably move over to questions now. I'm going to stop sharing my screen. And yeah, go to Q&A. What have we got? So, can it show monthly activity delay and logic change mitigation separately? Can it show monthly activity delay? Yeah, it can. So again, what you would do is, once you've run that traceback, a good question. Once you've run that traceback, you can then group and sort using the group and sort functionality. So the traceback isn't static. You can then manipulate and move it. And then once you're on that traceback, you've got your candidate scores. You can click on the candidates within the critical path, and then you can look at the changing nature of those activities over time in the bottom of the screen and the different files. So yeah, I've got a question from Tess. How do you purchase it? Good question, Tess. Tess works for us. So nice question. You can purchase it on our website. And we are more than happy to provide demos as well. So it's kind of download the 7-day trial. If you need support, contact us, and we can help you with training. And but if ultimately it should be a pretty seamless process just to download it. You see your logic key on the screen. You can download your application key. So Ibrahim, hi John. If we use different as-built programs with varying data dates, such as the monthly progress updates throughout the project, would we get different longest path activities? So let me think about that. If we get different as-built programs with varying data dates, yeah, and monthly progress updates throughout the project? Would we get different longest path activities for the same period? Yeah, I think you would. I think it's going to be what you got to remember what this algorithm, how it works. It's going to analyze the activities that are contained within that data file. And I'll give you an example of why you might get a differing result. If you assigned a different baseline activity, you may get or a different baseline, you may get a different amount of variance, which may impact the scoring attribute. And so look, if you can see changing as built dates across the files, you'll be able to identify that pretty quickly. So but I think it would somewhat depend on the baseline that you assign that may produce a different result. I think if you had a consistent baseline, what the algorithm might do, because you've got the other thing, I guess, the peculiarity of the algorithm, you upload all these activities. It's not looking at a file as such. It's looking at every activity attribute that was contained in the file. So if you've got, you know, 1 million activities, it's going to look at those 1 million activities and it's going to pick the best predecessor. So if you had one activity in one file that had different dates, so same activity ID, but they'd changed the dates in different files, so they'd unactualized and reactualized in a later version of the file, it would pick the preferred date, the preferred candidate, and then you would have to go in and do a bit of analysis on why it changed and why that activity changed between the different file types. That type of really detailed analysis is is definitely something that the software is designed to allow you to do. Good question though. You obviously know what you're doing. Stephanie Purser, can you change the weightings? So you can absolutely change the weightings. And so when you're looking at that scoring algorithm, at the moment, it comes with a default algorithm where we're allowing, I think it's 37.5% for logic, but you could zero that. So if you wanted to identify a purely non-logic driven path, and a good example of this might be where maybe you've got a design program in Microsoft Project and you've got an Asta program file for the build, and maybe you've got a procurement program in P6. What you can do is you can zero logic so that the logic no longer has bias, and then you can rely on the algorithm to navigate its way through all the activities in those independent files. So, and equally, if you know that you've got a particularly strong resource linkage within your file primary resource, you may up the primary resource component and, you know, reduce the logic. It's always got to equal 100. So however you maneuver the dials to suit your needs is up to you. What trend analytics does it offer? So in terms of the trend analytics, so the 4 that we had on the screen today or 5, I think we did, are the base trend analytics. We're in the process of adding more trend analysis to this platform. So over the next few weeks, we're going to be adding things like I think finish variance. So we're going to look at the accuracy of the reporting in the file. So if we can see that we're predicting an activity to finish next week on Monday, and then a week after it's completed, we see that it was Tuesday or Wednesday, we will report that variance. And so we're going to start running more analytics on the reliability of the files based on forecasting accuracy. And we've got a host of other trend analytics that are going to be coming online in the coming weeks. So it's certainly not a static tool. You're going to keep seeing new functionality added on a weekly and monthly basis. So I think that brings us up to the end of the 45 minutes. And look, I'm just going to finish off by saying we really appreciate everybody dialing in. It's new, construction's not good at adopting new technology. Everybody on this call, you know, hopefully you guys are the early adopters that will help us start to change the industry and improve the industry. We've got other technology that's coming online as well. There'll be other webinars where we're going to be presenting that. But a big thank you to everybody for dialing in today. and hopefully we'll work together and obviously reach out. I think there's we'll be issuing the slides, and there's contact details on the slides. And yeah, look, thanks for attending. Thanks everybody. Cheers.
Thanks everybody.